I'm going to give an example of trying to compute the definite integral given the graph of a function. And in this particular example, we can find the exact value of the definite integral. And why? Well, because we have line segments in the graph. It's made up of line segments. And therefore, all the regions we'll see will be either rectangles or triangles. For example, if we're trying to figure out the area between the curve and the x-axis, between -5 and -3, then it's a triangle. And we know what the area of a triangle is. The area of a triangle is 1/2 base times height. Okay, so how do we find this value of this definite integral? Well, we notice first that we're starting at -5 and going to 4. So we want to find the area between the curve and the x-axis as we go from -5 all the way to 4, stopping at 4. So this triangle, this first triangle, will be part of our area we'll compute, and then we'll have this triangle. And then there will be this strange region below the axis, but above the graph of the function g. And then we have up until 4. So we're going to stop at 4, and we're going to find this area. Right? We don't go any further because the last number is 4. So what we have to do is find the areas of these objects, these triangles mainly. And then what we really have to remember is that anytime we have some area below the axis, like here, we count that negatively. Okay, so let's get started. Let's compute some areas. So the area of this triangle, well, the base is 2, and the height is 30. Notice along the y-axis, the demarcations are 10, 20, and 30. So the area is equal to 1/2 times the base, which is 2, times the height, which is 30. And we multiply these things together. The 1/2 times the 2 is 1, so we end up with 30. So that's the area of this first triangle. The next triangle, the area is 1/2 times the base is again 2, and then the height now is only 10. And so that's equal to 10. Okay, then we come to this area below the x-axis, and we can break that up into pieces. There's this first triangle, there's a rectangle, and there's an area of this triangle. So for the area of the triangle, this first triangle, that's going to be 1/2. The base is 1, and the height is 10. And so that works out to be 5. So the area here is going to be 5. Now notice that triangle has the same area as this triangle. And in fact, that's the same as the area of this triangle. This is also 5. Then last thing to do is figure out the area of this rectangle. The area of the rectangle is, for a rectangle, it's equal to just base times height, not half base times height, but base times height. So for this rectangle, we have a base of 2, 1, 2, and then the height is 10. So 2 times 10, which is 20. So we have all these different areas, and now to figure out the definite integral, what is this thing equal to? Well, it's equal to, well, we take the areas above the axis, which are 30 for this big triangle, plus 10 for the next, plus 5 for this triangle here, and then we subtract the areas below the axis, which are 5 and 5 for the triangles, this triangle and that triangle, and then subtract 20 for this rectangle because they're below the axis. So we have 30 plus 10 plus 5 minus 5 minus 5 minus 20. The positive part is 45. The negative part is 30. So altogether we get 15. Okay, so that's going to be the value of the definite integral from -5 to 4 of this function g.